Hi guys, welcome to our first vector lesson, and we're just going to kind of get acclimated with vectors first, and then we're going to go into some problems. So a vector is something that shows direction. So most of the time we have like lines or points or whatever, and we don't care about a direction. This is going to definitely involve directions. If you have things that are attached to vectors, those are called scalars, and they do not involve direction. And we can get into that in a minute. So this is a lot of, this incorporates a lot of physics. So if you have like force and momentum and torque and all that good stuff, velocity, those all have to do with a direction. And so those all have to do with vectors. Other basic things that involve like physics, they don't. But if you can kind of think in your head what involves direction, we're dealing with vectors. So again, a scalar is just like a line segment, except it has a direction. So it has a beginning. And so we're just going to call this the initial point, and then this the terminal point. So this is not to be confused with a ray. So this does not like signify that it's going on and on forever. It is more like a segment. So it stops here, begins here. The next thing we're going to talk about when it comes to vectors is standard position. And just like we've always talked about standard position, the initial point is at the origin. So I'm going to talk about vector 3, 4. So you can kind of think about this as a point. Some things I want to talk about with notation, you will really see it 3 different ways. So you'll see it like this. You'll see where it kind of has this like half angle or arrow. You'll see it like that. You'll also see a bold W or bold letter. All of these things represent a vector. Also, when you're talking about a vector point, it has it looks like that. So if we have our terminal point at 3, 4, this is going to look very familiar to you. So the only difference is we've had that before, but now we're just going to include the arrow, and that means that we are interested in the direction. So it, again, initial point here, terminal point here, it stops. So it is not to be confused with a ray. Okay, so the next thing we're going to talk about is adding vectors. And this is a little weird, but then we can get into the, how do I say this, like algebra of it, and we'll find that it's not that weird. Okay, so the next thing, when we are adding vectors, first of all, I want you to plot the points. So you'll see I kind of showed the different colors here. And so technically what we're doing is we are picking up this vector and we're putting the initial side right here on the terminal side here, and we're copying that. So notice how we went up 2 over 2. So we're going to go up 2 over 2 here. And so that ending location, so now that is no longer there, and that ending location, that is going to be the answer to V, the vector V plus vector W, which is 1, 1, 2, 3, 4. Okay, so I showed you the graphing part of this, but I'm going to show you an easier way. So think about a lot of what we're going to do, it kind of feels like how we would handle matrices. So notice like matrices, we kind of focus in on those positions. So I have like -2 plus 3 is 1, and 2 plus 2 is 4. So you can literally just add the two components of each side and come up with the same thing. You don't have to do the graph. Sometimes in problems you'll need to do the graphs, but if you're just having like a basic adding or subtracting problem, I would just do that. So again, you would have like -2 plus 3 right there, and then 2 plus 2. And that'll get you in the same place. So what I want you to do is do these 3. Earlier in this video, I talked about a scalar. That's your scalar. So you're just going to take U and multiply both of those components by 2. So go ahead and do those 3 and see what you get. Okay, so I tried to show my work as best as possible, so hopefully this is not giving you any problems at all. Okay, so the next thing we're going to talk about is magnitude. And magnitude, that is the same thing as the length of a vector. So think about this. We had like the length of a line, and we've had multiple problems like this. So I want you to kind of focus your attention on this. And if I were to try to find the length of this line segment here, think about what you would use. So hopefully you thought about Pythagorean's theorem. That's what we're going to fall back to on trying to find the magnitude. So really a lot of this is nothing new. What is new is going to be the notation. So you'll see it 2 ways. So a lot of times you'll see me write it like this with the 2 lines. You will also see it in books like this with 1 line. I personally don't like it with 1 line because I think it gets confusing with like absolute value. So most of the time I will use 2 lines. Okay, so I'm going to do something very similar to what we have been working with. So let's pretend like I have this line. I'm going to call this 3, -4. Okay, so I'm going to plot, I say line vector, sorry. I'm going to plot this, and that looks hideous. I'm so sorry. And let's see. So we have 1, 2, 3, 1, 2, 3, 4 right there. So our vector is going to look like this. So we have, just like I said before, 3, 4, and obviously with Pythagorean's theorem, it's 5. And vector is the definite length, so the magnitude would be a length as well. So then our answer would be 5. Okay, so try vector at the point -4, 1 and see what happens. Okay, so again, once you did Pythagorean theorem, the magnitude of this vector should be the square root of 17. Okay, so for the next ones, we are going to do different things with this vector. So we already found this one. This is the square root of 17. What I want you to do is think about, well, what if we multiplied 3 to that vector? So let's go ahead and do that. So I'm going to multiply 3 to everything, and I want to find the magnitude of my new vector, which is -12, 3. So I want to find the magnitude of that. So I would do the same thing as I did before. So go ahead and find that length. Okay, so I want to show you something that's interesting here. So remember our original answer for -4, 1 was square root of 17. Okay, so when I do this and I simplify this square root, it actually ends up being 9 times 17 is 153. And so it comes out as 3 times the square root of 17. So I want you to see that pattern there. So this 3 can actually come out on the outside, if that makes sense. So like you're really just going to take your magnitude and multiply your final results by 3. Either way, it's okay. I just wanted to show you that you can kind of factor that 3 out and just take it normally. Okay, so I want you to do the same thing. What I'm looking for these two is, are they the same? So can we take the magnitude of vector v minus the magnitude of vector w and have it be equal to the magnitude of the two being subtracted? So go ahead and try that out and see what you get. And let me give you v and w. Sorry, I'll give you a new one. So let's say vector v is 2, -3, and vector w is 1, -2. So go ahead and try that. Sorry. Okay, so what you should see on this is that these two are definitely not equal to each other. So this is not something that you could break apart. This is something that you can kind of manipulate. Okay, so the next thing we're going to do is given these 2 points, we are going to find vector PQ. Okay, so this should look very much like what we're familiar with. So don't forget the vector component of it. It's kind of the same thing as like a coordinate point. And so we're not talking about magnitude, we're just talking about the vector. And so what you're going to ask yourself is how far over did you go? And we went 2. And how far up did you go? And we went 6. And so this is our answer. This is the vector for these 2 points. So I want you to do the same thing over here, and notice what we did. So to find this 2, 6, I did my terminal point minus my initial point. 3 minus 1, 2, 4 minus -2 is 6. So go ahead and follow that process for these 2 and see what you get. Okay, so notice that direction counts. So that shouldn't be obvious, or that should be obvious to you. It shouldn't be a surprise. So if we go PQ, so if we go in the direction of P to Q, I get 8, -2. But if I go in the opposite direction, Q to P, I get its opposite. So I just wanted to point that out. Okay, a unit vector is a vector with a magnitude, remember, length of 1. And so there are a couple things I want to point out. So there's 2 very important vectors that I want to talk about next, and I'm going to write those. Okay, so it is the I vector and the J vector, and these represent, the I represents the unit vector in the X direction, and the J represents the unit vector in the Y direction. I think I said J direction, sorry, X direction, and then the J represents the unit vector in the Y direction. And so these come up a lot. We're going to do a lot more with them later and in future lessons, but I just want to kind of introduce them right now. Another thing that I want to talk about is if we have a unit vector, we can use the unit circle. So this is really cool because, like, let's pretend that I have something that hits 45 degrees. Well, so I can use the sine and cosine values for that and then just multiply it by the rest of the magnitude of it. And so we're going to get into that. That is like a very poor explanation, but I'll kind of explain that as we go along as well. So I'll take one last thing is I just want to kind of introduce the I and the J, how it works. So if I had this 2, 6 here, I could also rewrite this as 2 times the unit vector I, and then plus 6 times the unit vector J. And this is just another way of writing this. So if you are in your test and you want to write this, that's great. If you want to write it this way, that's great too. But they mean the exact same thing.